energy efficiency components, as well as the building code, but again, at a really high level on it. So if you have any questions, feel free to chat it in or raise your hand, and we'll try to take some questions and answers. I've left a few slides to break this out. Sorry, I just got to get to the right screen. I got too many screens open right now. There we go. As part of the city's commitment to improving the permit process, these workshops have been developed to help our industry partners. The city will be providing the five, so this is the fifth one. The presentation is conceptual and formal education purposes only. I do have some recommendations to bring in some more in-depth consultants, and I'll explain that through the slide deck. The provisions have been generally represented. It may not reflect all the provisions, so I can give you a high level. I really encourage you to look at the code. Again, there's a mixture of where the bylaws requiring things that isn't quite, well, it's in harmony or harmonizing with the national code in energy efficiency requirements. So it's really important to spend some time reading it. So I just wanted to give you some aha moments in some of these slides. So it'll allow you to maybe spend a bit of time right into the exciting part of the code. We're at session 5 here, and as Nick had said, we're working on another project. I unfortunately a little bit behind on this and developing a larger guide. So I had a good talk with Richard and Nick yesterday, and we're going to develop a fairly robust guide to help homeowner developers, new builder developers and designers really get a better understanding of the whole process from pre-application, including zoning and engineering requirements, and how that's mixed with the building bylaw and the building code, and walking through the application, the permit review, the issuance, inspections, and then occupancy. So it'll be a fairly robust guide that hopefully we'll be able to do some more education on it when it rolls out. Design parameters. So we're gonna, as part of the guide, I've been developing this house. Unfortunately, I didn't develop it enough to show specifics regarding the insulation, mechanical systems, and building envelopes, but I will continue to do that. So a fairly simple home, a 2-story. I will intermix like the permanent wood foundations and ICF to give some design solutions on it. So we'll hopefully have that pieced out when the guide is produced. Our learning objectives today will be spending in 925, 26, 27, and then getting into the ventilation and mechanicals of 32, 33, and 36. If you wouldn't mind in the chat, I like finding out who's here. We got a little bit of a light crowd, but that's great. And hopefully some of you have had the chance to sit in other sessions. So if you let me know if you have sat in a session and what part of the design industry or building industry that you're in, I'd really appreciate it. Workshop content, if you have been watching these, this is from the National Illustrated Guide 2020, which is just newly updated and put out. It really helps me, and I think will help you kind of think about the building in itself. And it creates 5 categories: use and egress, fire protection, building structure, environmental separations, and building services. So in this session, we're dealing with environmental separation. So environmental separation and building services, those will be our 2 focus points. When we look at energy efficiency in those red boxes, it bridges a few of those. And again, it gives a good story of where we're moving in the code, or it does for me anyway. Continuing workshop series, these PowerPoints will be placed online as well as the recorded videos. So please have a look at those. Again, if you've sat in these, they're a little bit casual, they're a little bit rough at times. I have updated a few of the slide decks based on some communication I've had with the team or some questions coming in through the chat or follow-up email. So you may want to look to see which ones have been revised. There's new target levels. So Richard and team last year, and again, moving into this year, there's some really lofty goal set to improve the performance levels. And it really relies not only on them and their performance and getting their, big project online permitting system going sometime spring, summer, but it relies on you as the applicant and builders and tradespeople to ensure process, you provide good applications to ensure the team can meet these targets. Learning references, we have obviously the National Building Code, and we're looking at the Volume 2, Division B, Part 9 Housing and Small Buildings. We also have the updated illustrated guide that I look at. I've also included the National Energy Code, not necessarily because of what we're dealing with today, but it's a good reference point to look at and where we're going. But we're going to stick mostly into our Part 9 strategy here, as well as the Canadian Board of Harmonization and Construction Codes. And I'll bring that up a little bit later in the presentation, but they have some really great information, and particularly the codes being updated at the end of this year. And here, I'm working with the Housing Ministry and Municipal Affairs here in BC as a code administrator. So we're already in a lot of contact with what's going on national level, even in not only this 2025, but the 2030 national code coming. So hopefully it'll come at 2025, not a year or two later. I highly recommend for reading. Soul Plan Review is something I looked at a lot as a younger person, doing a lot of self-training. It's an excellent guide, and it's now all been digitally stored. So I've provided that link there. Mechanical Business is a Canadian-based subscription. I find it an excellent documenting for somebody who's not super technical savvy, the lingo for mechanical and plumbing systems, but it's a good, and they do from time to time give code references, so it's a nice one. And the illustrated guide to BC housing, it's a little bit dated now, a little bit old, but it is a good reference point, particularly since Whitehorse is mostly in the prescriptive measures, and probably will continue for a little bit while. So again, highly recommend pulling that link up. And also another one that I actually have the older copies here somewhere in my library, from school, from college, many, many years, if not decades ago. And it really breaks down the science. So if you have a little bit of a skew of wanting to know the technical aspects of it, you know, I would pick this up because the very first publication was humidity in Canadian buildings, and then they go on about efflorescence. They go about insulation and vapor barriers and air barriers. And again, this is not new. The science has been there for a long time. We just seem to forget it from time to time. So why we continue to have these kind of workshops. Also, the Whitehorse commitment, energy and greenhouse gas reduction. So you can check that website out. It seems mostly designated. We've got municipal initiatives happening. There's retrofitting availabilities, both with the city and with Yukon Territory. But again, you may want to have a look at this as well. In defined terms, there actually isn't a lot when we look at the two main topics that we're dealing with here, the building separations and envelopes, and then, the mechanical system. So these are a few of the time terms. The one I really wanted to, we have air barrier and vapor barrier. It's really, 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 really important to understand what those are and the differences between the two. And conditioned space, means any space within a building, the temperature which is controlled to limit the variation. So when we get into, some of the mechanical systems and where ductwork is running through, that could create some problems. I know it does here in BC, where in BC the code is seemingly different in 936 and in some of the mechanical requirements. And I think that's probably where the national code is going. BC has been an early adopter on a lot of these things, and it's outlined in that housing guide prescriptively. It's really great. Also looking at radon, there's when the codes will change again and increase some of the radon requirements. You want to be really cognizant of what conditioned and unconditioned space is. I'm just going to check the chat here. Spray foam. Oh, great. We got a spray foam loose fill insulation. Again, I'm not going to get into too deep. I'm going to just highlight a few points. But yeah, it's nice to see some suppliers and trades sitting in here. So if you have any questions, again, feel free to go into chat. We're just going to keep the pace going so that I can, let you go a little bit sooner, because now that it's a little bit more daylight, you probably want to get on top of your jobs quicker. So we have environmental separations that outlined in that one slide with the illustrated guide in the different categories. So we have heat transfer, air leakage and condensation controls. We have roofing, cladding, and stucco. Probably not a lot of stucco going on in Whitehorse. It's really dependent on the temperatures, because they have to really take care of the temperatures control there. And then the bridging, the 936 energy efficiency of the bridging. So before I go too far, there were some comments from previous workshops that I had done, as well as leading into this one. So as we go through, I'm going to try to have some slides that are going to highlight some of the staffing concerns that they have, and where either on a plan review or on site condition and site inspections, we'll have a look at that. So we have heat loss calculations and ventilation checklists, and how those are field installed and commissioned. That is the whole, they're whole two different things. One is the design and two is the install and commissioning. And I know Whitehorse is going to be a little more proactive on that one. We have installation of rain screens, or what we call in the code capillary breaks. Even though it's not mandatory, I do highly recommend it. And there's some good and bad ways of doing that. Slow slope applications, flashings, roof end for exterior claddings, roof ventilation concerns, and moisture content. I've been bringing this up a few sessions now. The aspect of, you're coming out of a cold winter and now moving into your shoulder season, but during that time you're putting a lot of heat and moisture, and you could have some problems, especially with these really thick walls and sealing them up, of them not drying it out properly over time, especially if, depending on the conditions that are happening outside. Climatic data. So this is referencing Appendix C. The climatic seismic information is really important here because we need to develop a lot of our heating performance levels based on our design temperatures. So in that highlight area, in other sessions, we've developed more into the snow loads and wind pressures. And as we look forward and perhaps even get more involved in seismic and lateral loading, understanding wind loading as well. Last session, I did talk about climate change. Or the last few sessions, I've talked about climate change. It is happening, regardless of how. So we're probably, you can see here, there's a website here, a web link I found, and trying to determine frost protections. It's based on some relative numbers. And this is an interesting website. You can see here that, even the freezing degree days on that picture has gone from 2178 in this time period, historical time period of 2005, and then now you're looking at significant drop. So things are changing. So we're going to see decreased frost step, which may be good unless you're way up north with permafrost. You could see increased snow loads, wetter snow loads. You see increased rain loads. You could have some stronger winds. We're seeing a lot of that happening in North America, where we're having these extreme changes in weather and conditions and increased wildfire threats. We're not really going to talk about that, but that may come into play later on as the codes change and you have greater concerns locally with wildfire interface areas. So just talking about the basic principles, understanding good building science goes a long way. Something that any of the courses I've taken, we usually try to talk about when designing a building is important to take into consideration building as a whole and how it relates to the property, and keeping the water out. The building's, really a living organism. It has a skin, it has a heart, it breathes, it has lungs. And if you think about that, and then you start with the building envelope itself, we'll go into depth more as we move along here. No wall system is perfect. There's always going to be a failure, so you want to try to build in redundancies. Um, so you want to pay particular attention to the science and understanding how the products and systems you use respond to each other. So you could have materials that are dissimilar and actually react differently to each other. So a vinyl decking material, something have bad reactions with like a blue skin, a peel and stick. They actually eat each other. So understanding the science of materials, but also how they work in combination with each other, creating the ideal wall system. So we're talking about a wall, are the 4Ds: deflection, drainage, drying, and durability. And again, we have problems, in Whitehorse, up north, and when we look at drying, I'm going to highlight that in a few slides. Especially with these thicker walls, water gets into the building envelope, has a lot less ability to dry it out like it used to in the good old days, where your heating systems would just dry your house out. We don't have that. There is a link to this little session here I borrowed. We have deflection, drying, and drainage, and durable materials and products. So we have deflection and drainage, probably the most important. The first layer of defense is the system to ensure design has elements to block out the majority of the water. So we call that a first plane of protection. You have your roof overhangs. Modern designs are kind of lean towards, especially passive house designs, and they've developed, again, some science principles around that, but you're not seeing a lot of overhangs, and overhangs are great because they help keep the walls dry, right? You see that in any light rain with not a lot of wind, how dry it is around the circumference of the building when you have to 18-inch, 24, 30-inch overhangs on it. Drainage, claddings are not perfect, so it's inevitable some bulk water will reach into the cavity. So one area you can drain it. Vinyl siding is really great at that. It has, almost a little system itself set up to allow it to drain and to vent. It also is a good insulator product compared to other products, but I'm pretty sure you're aware of that. And then not dealing with these, and I mentioned the kind of modern designs and the lack of roof O-rings, the lack of care of the attention to details and understanding what materials do. If you're not, you may want to look at leaky condo crisis. And if you're getting into more multifamily, you definitely want to understand and have a good designer and have your trades all involved in designing as well as in the construction process. Drying, again, just allowing that to dry out, whether it's time, you have cycles of the year that, you have wet seasons, you have dry seasons. But if you're trapping moisture in the walls for prolonged periods of times, even though you get a drying season, it doesn't quite dry it out. So then the next season you get more wetting and it doesn't quite dry it out. So over 3 or 4 or 5 years, you could have a problem with moisture building up slowly in your walls and causing problems. And again, using good materials, durability, good lasting products go a long way. They help you avoid callbacks, obviously, and they're a lot more resilient and they're good for the green environment as well because you don't have to replace it as much. So section 25, it's broken down into 1, 2, 3, 4, 5, 6 areas. I'm just going to touch on a few of these. So we have the basic principles, of the scope and application. So all walls, ceilings, floors, separating conditions. So that word conditioned from unconditioned space, the exterior air of the ground shall be provided thermal insulation, an air barrier, and a vapor barrier. So the three principles there. Sentence 3, insulation and sealing of heating and ventilating ducts shall conform. Again, you may have ducting going through unconditioned space, so you have to take particular attention to that as well. This picture, this illustration I showed when I was there in December at the workshop in Whitehorse. This is from the BC Housing Guide that I had mentioned earlier. And I've transposed, and on the right is the building bylaw, which again, it's kind of telling you this is what our thermal assembly should be, our size, in difference or a little bit different than what's in the code. And I like how Whitehorse has been proactive in that, but I do believe that there is discussions already happening with the building bylaw update and how that will move over into the national code part. But I did try to relate some of this. I was actually surprised, and I actually missed it. 4 no, I got the 4.9 right in the RSI in the top left. But I did the conversion over. No, I didn't. Sorry. I thought I changed it, but I didn't. The cathedral ceiling should actually be the same 10.57. As you can see in sentence 4 in the building bylaw, right in the middle of the screen on the right, ceilings throughout. 10 point. So I'll need to update that. I think I did on another slide, but we still are missing a few blanks in there too. So something we can work on together over the next few months. If you weren't aware of this, this is a really nice document. There is information regarding thermal assemblies and materials within the code, but this is a good reference point as well. It gives you wall, roof, and floor examples collectively to create effective RSIs as well as materials. There are some bolt-ins, actually some good bolt-ins. They just need to get a little bit of tweaking, a little bit of updating. And that's what we're going to work on as we move through this guides, developing the one main guide, and then I'll have little bolt-ins coming off it to express some specific concerns. If you weren't aware, BC has reached step 3 in the BC step code. We are now also in the zero carbon code at level 1, EL1. Nationally, they're called tiers instead of steps. But again, BC's been pretty aggressive in this area, and there's some specific information that you may want to dive into and learn about, as well as how when we move into the NBC. And I believe this is one the province is going to really do a lot of housekeeping on and update it because there's a lot of old and they want to make sure it's kept current. There's some that are really, really good education out there, just developed by BC Housing and RDH, or envelope consulting firm, just talking about some different ideas and different thought processes. They're really heavy on capillary breaks or rain screens. Again, I think solves a lot of problems, especially if you have a bad detail on the outside. You give a little bit of a break of it not getting in the rest of the building. But I would look at this. And the nice thing about this guide, it actually starts ranking, financially and how hard it is to do and the longevity of it. So it's a really, really good breakdown. And in talking about split insulation, you're in my perception of what's happening in Whitehorse because of the required 4.9 RSI, which is quite high compared to what we have even down here, and maybe similar to where northern BC is. But you're dealing with 2x8s, you're dealing with double walls. That's probably the most. We've been talking about ICF, insulated concrete formwork, as a possible alternative. Um, but you could also look at, exterior insulation but what kind of exterior insulation? So you'd see a lot of rock wall, rock salt, instead of rigid, because rigid is a great product, but it can come with some bad results if you're not detailing properly as well. So I'd mentioned ICF. I did a little bit of digging, I know there was a workshop recently. I wasn't able to connect with that with your local supplier, but they had a representative talking about ICF, I believe. You can let me know. This want to jump in. What Bob had written in Saskatchewan as a tier two, going back to tier one shortly. Yeah, they're going backwards. And again, sometimes you need to do that. You need to press forward, and if the industry is not ready or it's creating complications, and here in BC, we changed some of our new code stuff related some items regarding adaptability, because of the concerns financially, with the tariffs and things like that. So yeah, sometimes you take two steps forward and one back, and recalibrate and move on. But typically the tier one is not a lot. It's really good detailing and air barrier controls, continuous air barriers and testing, and then you move into the other parts here. But Whitehorse, you're probably like really up there already. You just don't know it. It's just probably taking care of some of your detailing here. But when you look at ICF is a great product. It has some limitations in height. We talked about in the last sessions too about its weight and when you're dealing with drainage layers and how thick those drainage layers get and the bearing capacity. So something to think about here. But when I found this little calculation left, it's from BC, but you can see it's reading in here the way they've calculated it is 4.03. So it's not quite hitting the mark of the 4.9, which is at the top, or the R28. So I went and found a product supplier. There wasn't a lot of new information I could find, but you can get something where you buy this product to a higher level, called platinum. And again, I'm not supporting any of these proprietary products, but this showing you some examples of how you could get that achieved. And then you're also looking at some advantage for air barriers, concrete pours in the winter because it's already insulated formwork. But you do have to look at the cost, the effective cost. You got concrete and reinforcing instead of your conventional framing. So again, something, and then again, learning, having a team learn that it takes a little bit of time. And I had one contractor say that's the quote unquote dumb tax, where you have to train and then maybe retrain as you go along and work with the inspection team. It's just a little bit costly, but after a while, I think it's a really great product to think about, and we can heat those marks. Another really great document from BC Housing regarding air barriers. This is an exterior air barrier. I've kept all these kind of learning pieces together. The link here, I've actually attached this onto drawings, like specifically when we're getting into details and trying to deal with flashings and air barriers and keeping that continuity. So this is another really good one to use as a designer and work with your building team out on site to make sure, in your siding trades, to make sure you're all there. So this is the item I brought about thicker walls. And this was a really great presentation I sat in beginning of closer to the beginning of last year. And again, it was produced by RDH, and there's another company that I'm also recommending to do some work with. But you can see here is, you can see from the top left that you get into, more interior insulation means colder sheathing. And you can see on the picture on the bottom is that this is just from really water getting in and condensation, and never over the cycles of the years, it never gets a chance to really dry out. And you have, chance for it just to sit there. And I believe that's vinyl siding on the picture there, but you could have any kind of material. And it slowly just sits there in this really dead zone. and creates that perfect condition where mold can grow. And then mold becomes not only structural damage, but it also becomes, mold getting into your house, and it's the sick house syndrome. So this is one example we've used a few times. Richard and I and the team have talked about this. The concerns are just something like a deck, and the deck has a roof on it. And over the course of a year and years, you have that cycle of it moving up and down. You can see already on the left, you already have a little bit, and again, this is a fairly new building. You already have a little bit of a detailing problem. So once you have that building moving up and down, it's probably not going to fall down, pull away. But again, if you had a deck scenario and a lot of loading on it, we talked about lateral loading in our framing session, it can actually, laterally just slip away. But you have here in this detail where water, snow will sit there, it'll melt because it's close to the environment, the thermal environment of the home. You get rainwater if you're not flashing it properly. So being very careful with your step flashing. That's another thing that the team had brought up. Instead of using long rows of horizontal flashing, you have step flashing to go along with your shingle orientations. But you can see your water can slowly get in there and slowly build up. And you go back to this where it's again water in there a little bit more, it doesn't dry out a little bit more, a little more. All of a sudden, wow, why is there black mold inside my house there? So yeah, those little details are can be a big concern. So talking about some of the concerns of the city, importance of keeping the bad insulation dry during construction. Regularly see the preserve or permanent wood founded in crawl space. You take a lot of precautions. There is items in the standard. I believe we also had some in the chat when we were doing the framing and the drainage. There are natural concerns with how this is set up in the crawl spaces and moisture being wicked into the building environment. Sorry about that. I can turn my phone off. Dealing with insulating building and adding heat when cold. So again, you're adding all this heat in, and if it's the wrong kind of heat going in, there's a lot of moisture, and that moisture freezes in the wall and it doesn't quite get out. I was, quite eye-opening for me to see some of the homes caked in frosting or frost, and just know that they're sitting in that OSB getting so you can see the OSB actually discolored because it was so wet in there. And again, what do? You slap the vinyl on or whatever material on the outside, and then you seal it up from the inside, and then you kind of got a pressure cooker going on inside with that nice warm temperature until you get to that extreme outside area in the blue area that we saw in those pictures. And insulation and roof venting. In this case, on this picture, I would almost think it's preventing some negative effects of drafts getting in there and blowing around. My own home saw a lot. I have these little dormers that have these little open areas that vent into the main roof, and they're actually a blast hole, and they blew all the insulation away. I didn't notice until I saw a little bit of mold in the bathroom growing, and I had to go and rake those areas and change the way that whole attic was venting in those dormers. So these little details again, paying attention. So this may be one of trying to circumvent that, of the swirling in the attic space during construction. Probably not so a problem in soffit venting is up. But remember, even though you have big heel heights, you also still need to get that ventilation in there. Air barriers. So required air barrier to leakage. And these are two separate things, air barriers and vapor barriers. Wall, ceiling, floor assembly separating, again, conditioned space from unconditioned space or from ground shall be constructed so as to include an air barrier system that will provide a continuous barrier to air leakage. So it's really important to hit on the continuous. That's super important. And a lot of the previous guides, BC housing guides, that little exterior air barrier. And I think exterior air barriers are really an excellent way to go. It allows you to kind of close that up as long as your trades don't come and poke holes. So that's another topic to talk with your trades is once you have a air barrier set up that you have, perhaps even have signs up saying, hey, don't put holes in here unless you tell me as a general contractor or developer, and we can either fix it or your team is fixing it and knows really what they're doing on that. The other thing too, again, continuity air barrier, and that's a 92531. So have a really good look at that. It's really, really important to understand that. In Whitehorse, it's really great that you do have some testing, some ventilation, air leakage control verifications, and that is outlined in section 87 of your building bylaw. This testing also goes in line with, we look at HRVs. HRVs are the predominant. They are required in residential units. And you look at capacities. So you look at the current national code and in the ventilation rates. And we'll talk a little bit more over the next few slides. You got 4 bedrooms, and it correlates to a table in the code. And then you're looking at the measurements here. They also talk about sensible heat recovery. And I didn't really give a lot of thought to this, but that's something that's really, really important up in your area because you do get these extremely cold winters. And as you're drawing air in at certain rates, you got to be really careful of how that is transferred. So you're not creating, condensation moisture issues on your makeup and your intake and your exhaust, I guess, and how those are set up with your system. So I just provided a little bit of information on that. So we have vapor barriers and thermally insulated walls, ceiling, floor assembly shall be constructed with a vapor barrier. So we have a defined term for that, so as to provide a barrier to diffusion of water vapor from the interior, right? So it's always going from warm to cold. It always wants to move from from a nice warm air to the outside, get into the expanse. And you also, I'd highly recommend read the highlighted area at the bottom, 92543, installation of vapor barrier. So again, we have an air barrier and vapor barrier. And in some cases, they're combined. In a lot of cases, they're combined with traditional construction. So we particularly have the 6 mil poly and they act as the air and the vapor barrier. So on the diagram, you can see air barriers stop the air leakage through individual holes. So anytime you're poking holes, so outlet boxes, little pipes, whatever you can think of as penetrating that air barrier, whether it's interior or exterior, you have to seal that up. It's really, really important because that is what carries the moisture with it, right? When you deal with the air barrier, the best way I was told from a consultant, Murray Frank, the course I took many, many years ago. He's another excellent consultant that you may want to look into. I don't know if he really likes code people like me, but he's a really great guy when it comes to building science because he's been involved in a lot of the repairs over the years and had not to have them in the future. But a vapor barrier is just this dumb membrane, and you could throw ping pong balls at it, and eventually one of the ping pong balls representing a water molecule may find something and bounce in. It's not going somewhere. It's just diffusing through, right? That word diffusing, it's a dumb membrane. It's just blocking the majority of it. It's the air barrier that's really important. Where again, especially in your area, we have high humidities, people aren't using the mechanical. That's why you have HRVs to try to control some of the mechanical ventilation and temperature controls on them, exhaust and intake. But as soon as you pierce a hole in the air barrier, everything's going that way. It automatically goes to there, and it's again drawing the water out. I can't stress that enough. That it is the most important thing to take care of in there. There is a new definition, and there's a little bit of note in the back of the code relating to the vapor barriers, but really can be combined. I'd recommend looking at possibilities of moving the air barrier to the outside because it has its own winds on it. And then once you get in the inside, your vapor barrier, again, you're not sealing the vapor barrier as that concern because again, it's that dumb membrane of diffusion versus air movement on it. I think I've beaten that one up enough, and we'll continue on. So properties and positions. So the last little bit within the section is this understanding like sheet and panel type materials have different values of permeability to vapor barrier, and there's a limit. And in some cases, you can even have paints, that meet this air barrier. There used to be a really long run of airtight drywall systems. Again, very problematic when you get damage to those systems. So I don't see a lot of those. But this is us outlining materials that can be prone. But in one area in here, there is an exception. So sentence 3, and that's always a concern. So isn't plywood and OSB a vapor barrier? So I have vapor barrier on the inside and I have now a vapor barrier on the outside. Well, they do. And again, there's a chart in the back of the code that they provide a little bit of lenience in here based on the thickness. So as long as you're not greater than the half inch to 12.5, you should be okay in this area. I know when the leaky condo part came up that people were putting ventilation ports in on repairs or cutting slits in them. Also saw builders, old school builders, cutting the poly and saying it'll never dry out. It's like, well, now you just kind of like now you got now you screwed up your air barrier and you're allowing more water to get in there and having bad details on the outside. That probably actually made that worse too. But um, plywood, that as long as you're controlling the thickness or USB, you shouldn't have that problem on it. But again, you want to make sure you're not getting the moisture from the outside or the inside to begin with. Properties of position of materials, again, just giving, I'm not going to get into too deep here, but you can, when you have these thicker walls, and especially if you have insulation on the outside, and especially if you have something like a rigid type material on the outside. So codes you can get away. I know this happens quite a bit in Ontario. I didn't notice it when I was up in Whitehorse, but they don't even use sheathing at times. They use like a rigid sheathing, so it really locks in. They seal it up. It creates a problem. So you really want to know through, calculation of your walls, your thickness. You want to get the RSI, but you also have to be careful where this magic line is on where you get possible condensation happening, and that's obviously not a good spot to have when it's inside your walls and it can't dry out on it, especially if you again have the vapor barrier on the inside as well. You could have some problems there. And again, just a reminder, the thicker walls. And I really think there should be a separate session just on that because even though you're maxing out at your wall assemblies for R value, RSI value right now. I know some builders are even beyond that now, really building some really elaborate, some very robust systems, but being very mindful that if you're not allowing that area, there is also new technologies of vapor barriers that open up. Um, they're still an air barrier, but they open up and allow a little more diffusion back and forth during the drying cycles of the home. But just another reminder. So roofing, we obviously won't cover all those, but those are all the things supplied on roofing. The purpose of roofing, this is taken from the illustrated guide. The purpose of roofing is to keep rainwater and snow melt from entering a roof space or attic. This is accomplished by means, of roof coverings and flashings that are appropriate for the slope. So again, appropriate for the slope, exposure, and shape of the given roof. So you have to factor all those in. The article defines the term roof, and roofing. A roof is defined as a slope or near horizontal assembly that protects the space beneath it. Platforms are effectively serve as roofs with respect to accumulation of drainage. For example, decks, balconies, exterior walkways, those are also treated as decks. If they do not allow precipitation, so you don't, if you have a vinyl deck, those are now a roof, whether or not they have something underneath it or not. So water ponds in these surfaces and wind can drive the ponded water. So that not only happens on decks or roofs, so the water, again, you think you maybe drain it off, but if it's sitting there, the wind will actually drive it to the sides. This is a big problem. And one thing I didn't honestly check what flashings in the national code in BC, because we've had these problems, these moisture problems getting into envelopes, wind-driven rain on the flashings, actually, if it's driving the water across the top of the flashing, it actually has to come to an end dam. And that end dam, so if I'm going to add a slide, if I missed it, if that is a requirement in the national code in Whitehorse, that's actually stopping that wind-driven water from getting in around the corner. Because when you've seen a repair for quote leaky condo problem, there's this window and then the big teardrop that's underneath the window assembly because all the water is just getting in because of poor flashing and again wind-driven rain getting to the side. So if you're knowledgeable of that, the other thing that really drives me crazy as a designer and person that's been in code for so long, why again, there's lots of really cool technologies out there, so I can see the temptation, but why tempt a problem? So you have these roofs that are butterfly roofs, and you can see in the top picture they have very deep gutter built-ins, but those are all membranes, and they're only as good as the person's and the materials being used in those membranes, and longevity. How long will those last? Who's maintaining those type of systems? Is it getting junk in there? Leaves and those type of things that are creating possible problems. Because in other sessions we talked about detailing to the part where you want to move moisture away from your building. So if you're detailing even a deck connection to the wall, if it has a chance to start collecting crud in it, then that leaves and that decomposes, it traps moisture in there for prolonged periods of times. So you look at the picture on the bottom, and again, this is just off the internet. You have a roof that's like at a 612, 812 pitch going right into the wall assembly. And it's probably, got some kind of elaborate flashings in there and peel and stick or whatever, but that's probably just not a good idea by design principles. Um, not great. It's good. You look at the top little piece there. You want to move the water away from the building, not directing it. And sometimes you see these modern designs where they have even the little entry canopy leaning back in towards them. It looks really funky. It looks really cool, but just there's so many moving parts, literally, cycles of the year. And then who's installing it, what materials are being used. Have you again dealt with any kind of overrun of the edges? That happens a lot again with vinyl decks where you're not really paying attention, where you have roofs coming even on a normal slope. You want to have kick out flashers to move that water away from the wall so it's not dripping and kind of teardropping around the end. But yeah, just my recommendation. It looks cool. You can probably do it. But again, are there specific warranties involved to do that kind of design with your roofing contractor? And again, plowing it into the side of the wall over time is probably not the best idea. But that's just my opinion, not the city of Whitehorse. So I asked the team the top three roofing materials in Whitehorse for residential construction. So by far, it's shingles or asphalt, Duroid. We have metal roofings, and metal roofing is great. There isn't really a third choice there that was really prominent. You can let me know if there's a product out there that's being, ascending. But, I think the most part there's the code and the applications of code, but you really want to make sure you understand the manufacturer's specifications on it. You want to really understand the roof slope limitations. I had thought metal roofs had a little more latitude to it than it actually does. So you want to understand the limitations of those products, especially in the specifications. When you ever read the specification, try to find the part says there may be some limitations to it. Of use. And you find that in a lot of product specifications, especially if it's been tested by a Canadian agency. It'll go, this is the product, this is what's been tested to do. Say, I had used the example of fire tape. Fire tape is actually a real thing. It's a pink roll of tape. It's used in areas where you're not finishing, so maybe in a garage or in a crawl space or a service room where you don't want to mud and tape it. You have to mud and tape a fire separation for smoke, but in this case, up until recent that product, when I looked at it and had to fail somebody, it's like, this is great. I read the testing. You've put it in the way I think it does. In that case, it was an architect involved, it was a smaller project. So, okay. Unfortunately, reading the limitations, you cannot use this in a horizontal application. And the person obviously got a little bit upset because I failed them, needed to fix it and replace it. And I showed him the specification that he gave me. And I came back the next day as a highlight and said, did you read this part? So again, be very careful when you're looking at materials, read the specifications, and codes are talking about and referencing manufacturer specifications more and more now. So it's just one more thing that you and the building official needs to stay on top of. So back to this low slope concern, so asphalt shingles, and again, just to highlight again, the platforms is subject to snow. So not only now it's an occupancy and you have to deal with the snow loads. And I believe we had looked at the snow loads for a platform versus the snow loads that you have for loading. They're the same. And some communities where they have higher snow loads, those become the predominant factor in sizing structure. But in this case, you kind of got a wash. But you can see from the chart within the code of roofing types and slope limits, there's actually a minimum slope and there's a maximum slope. So you have to be really cognizant of those when you're picking your roofing materials. And then just a little note there about ice damming. So section Eve, 925 section, Eve protection. I'm going to fix that typo. Protection for shingles and shakes. So it really relates to ice damming. If you have those, Canadian, houses, you see all these icicles. You've seen it from forever. It's been in movies, those kind of things. But there is eve protection because it does happen, and it really, again, dependent on what's happening within the building envelope and your roof overhangs on here. So it gives that outline. This is a picture from the Illustrated Guide. They give a really good outline of this. But again, what are other ways of perhaps preventing ice dams? Ventilation is probably a good, strong point on it. One thing that just popped up the last week or so, this is one of the companies I'd seriously, tell you as a building industry group, as a city, um, to perhaps put on some very specific sessions related to cold temperature situations. This is a free online course you can take. I put the link on here. I'll be sitting in and watching. They have a lot of other videos they can watch too. So again, um, I'm more of the code guy, but I think these kind of consultants are more of the practical side. And I think it'd be well worth it if your team could bring that together as an industry. And again, this one specifically, because codes are changing. Tighter, you're getting tighter assemblies. You're not getting as much moisture in there, which in the roof, which is great. But you're getting thicker. And again, there's other problems now occurring with thick insulations, and they call that shadowing up in attic spaces here in the lower mainland where they're cooler now, and you're getting humidity, condensation, humidity. You get actually getting uh, moisture issues now in the roofs that you never did because you don't have that warming coming leaking out through the roof assembly and kind of helping things dry out there. So you know, two steps forward, one step back sometimes on the technology. Asphalt shingles, again, another thing that staff want to make sure if you may get, I'd showed that kind of funky design where it had two split roofs. Typically, you'd have the one top roof and then you'd have a lower roof like that. Well, this one might be a little bit lower. So you may be asphalting, Duraid shingle roof, but this one's, this may be 5, 12, and all of a sudden this is a little bit lower, just with aesthetics, and you may have some lights or something up there. There's certain precautions you have to take, and then it starts with securing the tabs on here, or this is the last section in here, roof drains and drain spouts. I just wanted to make mention that when we're dealing with part 7, it's a storm water management system. So we're dealing with roof and sites, and the downspouts, we have nowhere really to go other than away from the building. So we talked about a lot about that when I was there at the workshop. And in session 2, there is actually quite a few slides regarding the city requirements related to moving that water away from the building and moving it around. So we got a bit of chat here. Seeing an air barrier tightness will prevent ice damming. Yeah. I'd suggest only in combination with adequate ventilation. Yeah. So it has to be a combination of, because again, like I said, we're making advancements in one way and then perhaps causing problems in another, and you have to really take care. And when, I was involved in the leaky condo repairs, it was just a matter of like, they did one thing right, but then they did something not so great. And then it really opened up how poorly exterior detailing was being done, and there is no more grace on the building heating itself out and drying itself out. There was no more of that. And again, just the change in the way people operate inside. Even though you have mechanical ventilation systems, people have to operate. It has to be commissioned properly as well. I'm going to speed up here a bit. So cladding, really want to focus on the second and first plane of protection. So the main purpose of cladding assembly is prevent, we talked about that, the 4Ds, to prevent the entry of water into interior space and into compartments of the building enclosure that are vulnerable to water. Each type of finish requires specific accessories such as trim, sealants, flashings, and make sure they're fastened properly. Cladding must be designed and constructed to fill following function. So deflect snow, we talked about that, rain, and even under wind pressures, allow for the drainage or dissipation of any moisture from behind the exterior finish, protect backup materials and wall assembly from mechanical damage. So again, there are limitations how long sheeting papers can be exposed because that degrades it, and then just some foam products that actually we had some problems here in the lower Okanagan where they were using a really great product, an exterior insulation, but unfortunately they couldn't get the trades organized or something happened, and that product was left exposed for too long, and actually they need to remove a lot of it to a very upset builder that needed to remove it on there, but they had a product that had limitations to that. Provide reasonable durability as well. So cladding in Whitehorse, staff had let me know that vinyl seems to be the top of the list, and that'll be our kind of our prime example house that we're using vinyl in and looking at different. It does have properties for insulation, which is actually even better than hardy plank and hardboard. Again, but sure, you read the specifications on it. There's also the code, but things like grounding clearances and limitations of those products, spacing of fasteners, there's some limitations to that too. as well, especially when you get into rain screen applications, just being aware of those. Cladding, we're minimizing, except for exterior walls protected from precipitation or where it can be shown that participation ingress will not adversely affect occupant health and safety. That is a bit of a hard one to negotiate. There are some examples on that. So, you're not really getting into, I would just say treat it all the same. Don't worry about potential exceptions of being covered or yeah, in an alcove or something like that, where except where exterior walls are protected in sentence 2 from specific mechanisms of deterioration such as mechanical impact and ultraviolet light. Exterior walls shall be designed and constructed to minimize the likelihood of their required performance to be reduced to acceptable levels. So there's some explanations within the illustrated guide for that. I wanted to show and highlight, again, we're talking about the 4Ds, first and second plane of protection. And as the code moves forward, there will be some new detailing requirements related to that. So you have your sill, your basic sill protection. You can see on the picture the head flashing. That head flashing actually has an upturn, so I'm assuming that that is a national code item, or it soon will be. I think it creates a really excellent. So you have your membrane, your sheathing membrane on in pink in here, and obviously gravity is bringing everything down. You may have water ingress around that opening. The window may fail, perhaps as well. You want to be able to move water away and down and around that building there. And again, the flashing at the bottom to pull it away from the building. The one on the bottom here, this diagram is looking at your capillary break, your rain screen assemblies, and there's a little more detailing of that. They also add this when you look at the window opening on the bottom right, rough opening sill protection that extends to the interior face. It's nice to see, and then you'd rod and caulk that assembly as well. So there's some really good information about the first and second plane. It's really important to understand that, especially if you're not using a rain screen system. Rain screen help compromise, help resolve other issues that perhaps some sloppy detailing causes on the end on your exterior cladding finishes. And you really have to pay attention when you get into rigid insulation. Even though it's a great product, you have to be really careful with your detailing, because once the water leaks in there somehow from the outside, it's really hard for it to get out, especially if you have the barrier, the vapor barrier, the air barrier on the inside. Something we talked about workshop on the right of that picture, they did it great. Again, being very careful of the spacings of those based on the type of product they're using. But again, even though capillary is not required, I do recommend it. It's just be careful how it's installed, because if you do, again, you're getting that movement away. And again, it's probably because of the exterior cladding material that's used. Ran into that when I was doing a few homes with cedar shakes. It's like, how do you do that? Because the cedar shakes need to be horizontally attached, and I'm moving away. So it's actually a double strapping scenario that we ended up having there. And BC Housing Guides have a lot of really great items on that developed by RDH. But yeah, just be mindful that if you have that now, water gets in, and especially around the windows and doors, that you're just trapping that water there, and it just sits there. And again, like I said, if you have poor detailing, water sits there, eventually will probably want to go the wrong way. It's not going to dry out if that material won't let it. Flashings, be really careful with your flashing, especially in these deck areas. You want to make sure that you're moving the water away. Roofs, I mentioned those kickouts at a lower roof to a wall. You want to make sure moving those away. And there's some really great details in there. Different materials, the code's pretty specific about the similar materials you need to flash. So obviously, you could have a belly board, you could have a brick veneer, those type of things on there. Not a lot of flashing going on. It looks like there's a little bit. It could be a J mold in this last picture on the bottom, the vinyl, or it could be the flashing. But you can see it's away, but there's no end dam. A lot of builders don't like putting flashings because it doesn't look good, especially if you have to bring the flashing beyond. So that's something I do want to also check in your code, because here's in BC, it has to go beyond the window frame or the door frame, the end of the flashing, and then do your upturn on it. And again, it doesn't quite look cool at times if you're achieving a certain look in there. So really be careful. And I'd probably just answer my question if I just would have read my slide. Terminate at end dam with a height in millimeters not less than 25 millimeters or 1/10 of the value of the 1.5 driven rain. So again, going back to climatic chart there. So you already probably have that figured out, but unfortunately, the installation done over last year proves that it's not being done. And it's hard to catch that for the building official because they see it at final. And it's like, now what do you do? Right? Because that's really hard repair. And it could be a significant problem in the long run. If that's not going to get done and you have thick walls, water's getting in there, you could have some really big problems happening there. If you have any questions, please put them in the chat. So we're going to just run through building services, ventilation, heating, and then that crossover with the energy efficiency. So the city requirements, a little harder line, I think, moving forward. Everybody's a little bit behind on catching up and keeping up, but I think especially as new codes are rolling out at the end of next year into early 2026, you have to take a lot more attention on the energy efficiency part and how these systems are all working together. So we're looking at heat loss calculation, ventilation calcs, and that's um, probably taking a little more time to ensure they're designed properly, a little more time to ensure they're installed properly, and then commissioned at the end. Ventilation, the purpose of ventilation, maintain a healthy indoor conditions for occupants. Ventilation for occupants must not be confused with ventilation requirements for the structure. Ventilation requirements for unheated crawl space and attic space are dealt with in another section. We're dealing with mechanical ventilation. There's also non-mechanical ventilation, but we're just going to stay in here. So we have the required ventilation for every residential occupancy will incorporate non-heating season, except as required in sentence 2 and 3 is supplied to electrical power and heating system. Self-contained heating system, ventilation system serving a single-family dwelling. So those are the two main ones that we're dealing with in here. Required ventilation, mechanical ventilation systems complying with the balance of the section shall incorporate at least the following components, and these are all together. Principal ventilation system complying with supplemental exhaust fans complying with article and protection against depressurization. So you get these large fans. You can actually ask them. I don't especially get into this slide, but you have to be very careful about, especially if you have naturally aspirating. I'm not sure if that's involved, but it may be if you have a reno, you have an older type setup, and then you do a kitchen reno and you put a big fan in there. It's not great because especially with your temperatures in the winter, makeup air, you could actually have some significant problems in that area. The principal ventilation system exhausts stale indoor air from the kitchens and bathrooms and supplies and distributes fresh air, outdoor air to specific locations throughout. Each ventilation system has four main components: outdoor air supply, distribution, controls, and indoor air. The principal ventilation fan operates at a known rate as a normal operating exhaust capacity. This rate is intended for use on a continuous basis at a time when that ongoing background level of ventilation is needed. And the section of the code is here, the principal ventilation system. And this is taken from the illustrated guide. So this is one that's really important when you're looking at ventilation. I'm going a little bit quicker now, so we can fit this all in. But you do have, this is a requirement in the bylaw. This is an excellent thing to have in a house just for a number of different reasons, comfort and health. And you have tighter buildings. This is really, really important. It's about the commissioning of these. You do have the testing scenario. You just want to make sure it's this is something that was a big failure point when they really got heavy into HRVs here, especially on the lower mainland in BC. They weren't being installed properly. Nobody really knew what they're doing. They're even putting them backwards where the access doors were actually against the walls. Again, you hope that wouldn't be a problem, but it was. But commissioning to make sure any type of mechanical systems are working properly. If they're not commissioned properly, it becomes really problematic, and you lose the trust of the people. Heat pumps is another one becoming more popular. But if they're not designed, they're not installed and commissioned properly, it's a big loss to the industry, that mechanical industry, and probably I have recommended this here in BC that there probably should be certifications for mechanical contractors, especially ones installing heat pumps, especially in a really cold climate where it may be kicking off and it's actually drawing a lot more energy to maintain certain temperatures in there. So when tested in conformance to low temperature thermal ventilation tests, and it's just outlining these limits here, and I believe this is also within the bylaw itself. So ventilation exhaust capacity of a ventilation system is sized based on the number of bedrooms. in the house rather than on the basis of some fraction of house volume. The number of people in the house, which is usually related to the number of bedrooms rather than the size of the house. I think that's a good standard to have on there. In many households, ventilating and continuous rate may result in higher heating bills. So obviously a big factor in Whitehorse and lower indoor relative humidity. So you have to be careful in those areas because that could create significant respiratory health issues. People don't, I mentioned the sick house syndrome. You may have, a wet building envelope environment, but you may have a really dry environment in the winter, and there's a certain limit of percentages and if you have a dehumidistat switch, there's certain dials limits there. But if it's too dry, you're always tending to be sick because all this dries up. You find out in the plane, you dry up and then you get sick, and that's why some people kind of moisturize the inside of their nose. That's really a reason of being concerned about that. And when you look at again the heat recovery ventilator, and you're looking at the minimum standards, and we showed that test, that test for the ventilation, it really relied on the number of bedrooms, and then that moved into heat recovery ventilator. So that's all outlined in the code. And just another example of the code here when you look at section 88 and 89 as a principal ventilation fan to satisfy the requirements of the National Building Code. So that would be your heat recovery ventilators, HRV, and the ventilation should be installed at a time of rough incident inspection. So we want to make sure those are all in so the inspectors can go over that. Any buildings requiring mechanical ventilation shall have heat recovery. So it really runs the gambit in those areas. Some potential, this is from the back of the guide or the code, I can't remember, but it gives you some examples of a standalone requirement. This could be electric baseboards on the left. You have some fans. You may have some makeup air. So, but again, you have to be really careful in your colder temperatures. But you have the principal ventilation is the HRV and how it's distributed. If it's running through the attic space, you have to be very careful about your insulation values in there, and you want to look at those parts of the code that relate to that of unconditioned spaces. Or you could be in combination with your furnace system, but being very mindful of how those operates and the flows that they operate in. That's why I'd highlighted in that one chart, there's that critical zone of the flow rates and the way that air is moving in and out of the building. Clearances for air intake, heating and air conditioning, just, looking mostly at the baseboards, we have forced air. There's a combination, oil, propane, electric. Heat pumps is increasing again, being very mindful of who's designing, installing, and commissioning those. There's also concerns with condensate and being able to drain any of these type of products, HRV as well as heat pumps. Most heating systems seem to be, again, going to electric, and that's probably related to the green rebates. I'm not sure if this was the proper link or the example. It's a Yukon or Whitehorse has its own specific rebates. I couldn't see that. But as mentioned, the city is going to develop those a little more, I think, as we move along, because as buildings get tighter, as wall assemblies get thicker, I think we really have to pay more attention on the ventilation to keep people healthy and ensure ventilation. And you may even get to the zero carbon code on how those appliances are working there too. Related, so heating systems, we look at outdoor temperature, and that goes back to on the bottom here of the slide, goes back to our design temperatures. So that 2.5, which is really threw me for a loop when I saw that for the first time compared to here in the somewhat sunny and warmer Okanagan, minus 41. So, I really feel for what contractors and especially as the codes change and the trades really need to keep up the speed on the efficiencies here. So this is one example really on TECA. TECA is a really great organization. I'm part of it. I'm not a member anymore, but I've done a lot of education through them as a building official and designer. So it lays out a really generic process of checking. So we have a ventilation system, so it's a dedicated HRV. There's orientation involvement, the air tightness. So we have a minimum air tightness of 1.5. We have some stipulations of rough and open terrains, and those come in from time to time in different sections of the code. And then the outdoor design temperature that we'd stated on the other slide is that 41. So all those check. The only concern that I'd have in here is when we look at the number of bedrooms versus the number of people. Typically, by occupant load, it's 2 persons per bedroom, so that perhaps should be six, not four. I'm not sure if it makes a huge difference when we're doing these calculations. And then they'd get into a little more detail about the building envelope elements. And this will be more, or could be more problematic, or something to really to watch for as you move into the tiers of the performance levels of the step code, that you pay really attention that your design drawings, your heat loss, evaluations, your calculations, and your step code performance reports all match. And that's going to be on somebody, whether it's the designer, the applicant, or the builder. That's something that staff will have to make sure they're on top of as well. Field burning appliances, there's a specific process for that. So that's outlined in the building bylaw. All section 90 here, all new construction chimneys and natural aspirated, they have to vent through the building envelope, which is great because you want to keep those in a warm environment so they're actually working properly and they prolong the life of your appliance. If you're not aware of wet energy technology transfer, really great information on that technology. So I'm not sure if that's in the Yukon or not. I'd recommend them perhaps as another resource tool for educating if that, again, if you're looking at pellet stoves. And nothing saying you can't use wood heat, even in the energy code standards or even in the carbon standards. There's ways of using that as well as you move into those. And then the old fire appliance, there's a specific kind of occupancy sign off on it. So it is a very specific system, and you have testers and installers on that. Near the end here, so energy efficiency. So just going to highlight a few of those within this section. So it's the bylaw. The bylaw itself is proactively aggressive on the thermal assemblies, the RSI values, and also kind of mixes in a few other things regarding energy performance. So we have the energy guide, the labeling, which again, I think is really great because, house is like an appliance. Why, if you're competing in the market and you can show that you're rating at a higher, that's probably a better performer for somebody buying that. When you're looking at energy use for the building, somebody has their mic on. Energy used in a building. Energy used in a building is equal to space heating energy loss and the gain through the building envelope. Losses due to inefficiencies of the heating equipment, energy necessary to outdoor air to ventilate the building, and energy used to heat the service water. So all these little factors in here. Again, just pointing at some energy efficiency guidelines within the code and how those relate to the building bylaw right now. Again, that may change as Richard and team are updating the bylaw, and they may just go follow the tier within the National Building Code within the climatic conditions and requirements. So the building envelope, we always want to intermix those. The energy efficiencies is a bridge between your building envelope and the energy efficiency portions of the code. So we look at subsection concern to loss of energy due to the transfer of heat and air leakage through the materials. So through the materials, components and assemblies, including the interfaces forming the building envelope of that conditioned space, that defined term. Requirements in sentence 2, the subsection applies to the components of the building envelope assembly that separate a conditioned space from adjoining storage garage, which is usually unconditioned space. There's sentence 3, which talks about the inclined walls. Whether it's not, you don't really see that a lot anymore. Maybe in some of the more funkier modern designs, you might start seeing that again. What's a wall and what's a roof and how you insulate those. Properties, performance to installation of windows. So in sentence 4, we're covering that, and the properties and location of the installation of thermal insulation, air barrier, and vapor barriers, as is outlined in 925, which we relied. So some specific things out of the code, and looking at zone B, where Whitehorse is sitting in relation to the very far left of the slide, you're looking at the bylaw. You can see there's quite a bit difference in relation to that, and it's probably because of your permanent wood foundation setups there. See you, John. Thanks for attending. So there's some differences there. We're kind of close, or a little bit behind in some ways and a little bit ahead in others. So when we come out to the national code, and those may change as well. When we're looking at opaque assembly, so that one there was below grade, so your foundation system. This one is above ground opaque, so your walls and your ceilings. You see some differences here, especially when you're getting to cathedral ceilings. There's obviously quite a bit of difference in here, and even those parallel chord systems may have to be quite deep if you're doing a cathedral ceiling. And then your walls are a little bit higher too, so a little more aggressive than where the national code is at. And then your fenestration, your windows, your doors, your skylights, those type of things. And there's some very specific things in here. So in your bylaw, which is at that right middle part, doors excluding glazing, and then windows and glazing. So you're 1.4, which is matching. And then you have skylights down here. Yeah, just showing this as an example and look at trying to update this. I think it's a nice tool. So you can see on the top left, I did correct it on this slide. I don't know why I didn't on the other. So that really caught me. That's quite thick. I'm not sure why code actually has allowed it. Quite a significant reduction in it right now, but maybe that's something we can look at as code people or my team. Just again, talking about air tightness, how important that is. It's within the section, within the code of 93629. It goes into that. I'm not sure, again, perhaps somebody can write me back and let me know that, 1.5 is the bylaw. Is there a specific thing within the national code? I did look at the modeling and it's talking about 3.2 and 2.5 air changes as kind of the base. Well, if you're to, yeah, and I know some homes have been designed to the performance and modeling. Is there a minimum standard? Or is that, again, by the tiers? So you can let me know. I didn't dig into a lot of that, to be honest. I did want to show the chart of where if you are wanting to do performance, or where it's going on the different levels. So we have the performance tiers and those columns of 1, 2, 3, and 4. And 1 is, again, and even 2, it's probably just your detailing and your airboard testing and getting that right. And as you move into 3, 4, and 5, that's when the mechanicals and maybe your fenestration is changing. In 5, you're moving more into that net zero ready complement that we're at. Where are we going? Future of energy efficiency. If you go to this link, so within the upcoming 2025 National Code, you are seeing some changes proposed, and you can go online and see some of those changes I showed some of those for the cladding. But when you look at the bottom of the slide, you got climate change mitigation. So that is refining the energy efficiency tiers, climate change adaptation, developing solutions for overheating in indoor environments. That's somewhere BC has already adapted cooling requirements in one living space in a dwelling unit because of the significant heat dome deaths. We had hundreds of people. I would probably say more elderly people in a 3-story old walk-up building or a senior home that didn't have quite good ventilation mechanical systems in it, not necessarily in that single family, but it's come across us as an F280 requirement to look at a cooling room or a cool room. And it's a life safety. It's 26. It's not cool, but it's going to probably keep you alive versus a room that gets into the 30s as an elderly person. Alteration to existing buildings, that may be something as well to look at as codes come online for alterations and looking at tier performances for alterations. Just a reminder again, building permit application process. Greg, yeah, so we're at tier 3, so that's fantastic. Not a requirement, but it's definitely something to shoot for. And where BC is at, and a lot of this builders found out quite quickly through their testing at even when we're at step 1 in some of the communities here in the Okanagan, they're already at 2, 3, and a little bit of tweaking of their team, and easily getting to 4. Not a lot of changes on it. And step 5, again, that's where you kind of saving the planet and those type of issues. But I do believe that that's the way we may have to move. And we are in BC at 2030 or 32, it's net zero ready. So looking at passive systems as well. So applications, really be diligent on looking at and again, apply early. I've been harping on that the last few sessions. When you look at your design drawings, your application forms, I've highlighted a few of these areas. Be really cognizant of your detailing. It doesn't have footing insulation, so you will probably want to put footing insulation into those, your elevation plans. Detail out, your floor plans and your elevations and your cross sections. Be really consistent. I'm working on developing an online application process and minimum drawing requirements. And a lot of it is outlined. If you have it in the cross section, show it on the elevation, show it on the floor plan, or highlight it, the specific components. But really be careful. Put it all in, because as soon as a building official has to start guessing, or again, things start changing out in site, it's really hard to deal with it, especially if you're not cognizant of the materials, you're not cognizant of the roof slopes. It could really create a lot of problems on it, and especially when you get into step code or tier performance. You start changing the parameters and moving windows around, it becomes really problematic, or they don't align your F280, your tier code performance reviews and your building drawings don't match. Then it's just like, what is the building official supposed to do with that if you're trying to perform at higher levels? So floor plans, cross sections, just make sure you have your RSI values, your assemblies, your air barrier locations is really great to just draw that extra line of that continuous from foundation all the way. If you have a jog out around into the roof and around, it's really good to highlight that in a bold, maybe even a red line. We call that a red line down here. Specifications. So we have some paperwork to bring in. You want to be, again, matching those with your drawings. You have inspections to very specific inspections. Some of these are benchmarks where, again, if you don't have the paperwork, you don't have deficiencies dealt with, and that's somewhere where the building official could put a stop or hold and say, hey, let's make sure but we do have some, items in here. We have radon and insulation. We do have building envelope requirements in here. So have a look at, this one is posted or make sure you have those requirements that under your condition letters. I've highlighted engineer truss areas, but really you want to have your heat loss calculations at framing. You want to have all the installations mostly in place. So it can be a verification and staff are moving towards looking at that. Insulation of air barrier, again, another benchmark where, again, you want to have that all in. You may need to get updates if you change things around, especially if you're doing tier performance, you start changing parameters, insulation, wall assemblies, window locations. It all makes a huge difference on the performance. So this may be a stop. You can't go further beyond here. You have to be very cognizant of the moisture contents too, especially coming out of the winter into your shoulder season. Part of that frame is also mechanical, so you want to make sure the mechanicals and those paperwork are all up to date for what's being installed. It's really important for the designer, especially through unconditioned space and having the detailing of the insulation requirements in those unconditioned spaces on the drawings, but also being ensured they're being installed correctly out there. Some very specific outdoor occupancy requirements. I'm just going to skip to this one. There is kind of a two-step, even though it's a parallel review process with most of the smaller housing developments. You need to get your site grading and that development permit process dealt with first. It's recommended to deal with that first before you call for your final your occupancy. It's really important to get all that peripheral stuff nailed down, get all your paperwork in, allow for the building official to look through that information, make sure that DP is signed off. It shouldn't go really the other way. You want to make sure it's all closed properly, even though you're not really dealing with life safety, but the team really wants to make sure that happens. And again, if you have any doubts, reach out to the team, to Nick. It's unfortunate there's been some health issues. I really feel for the families and those persons going through that. But again, reach out. Highly recommend looking at some of these organization HDR building knowledge, coming in either doing a webinar or in person, looking at some mechanical ventilation, maybe looking at some certifications and permitting, or more robust permitting, especially swapping out mechanical systems and adding heat pumps, because you also have to look at ventilation. How is the air in a house moving if you take the furnace system out and put split ductless systems in those systems? So TECA and HRAI are really great. I'd like to thank you for joining in the last session. I hope you found some value into this. I went pretty quick again. Now working with Richard and team, they're developing a very robust development guide. I think it's great. Hope they can do some breakout sessions related to development as a whole. We're going to also do some development or building permit as guides and bulletin updates. So really encourage you to add some feedback into the sessions, how we can develop a guide that really help you as a building industry team to stay consistent and to move forward together. Nick?
Yeah, so again, big thanks, Ken. I've really enjoyed the webinars that I've caught and the couple that I've gone back into the city page and found. So yeah, for the industry folks, these get posted on the city page along with Ken's slide deck. If you have any questions and concerns about today's, get them to us and we'll try to incorporate them into that ahead of time. You should see them go live in about a week or so. The other four are up and rocking. I think the other note to close on, Ken alluded to, ongoing changes at the city. We've gone through a couple of small reorgs in fairly short notice because of some passings and health concerns and a whole bunch of other stuff that we don't need to get into. But just to throw it out to the industry as an early heads up that you've got to meet me here till the end of April. We've got a super solid replacement coming in to manage the department right through the construction season to the end of September. We'll share those details when it's formalized. But further to that department, there's been a shift at the city here where we're actually taking the inspections group wholesale out on their own, creating a standalone department. That's beginning April 1st. So you'll see the inspectors and the bulk of the admin crew come into some department that's not quite named yet, permits and licensing, something like that, buildings and permits, who knows. We're not asking for suggestions, but I'll laugh if they're funny and you suggest them for sure. The other end of the department, the development officers and our subdivision land coordinators, they're going to be reassigned to another new department as well. We're going to steal the whole private development crew from engineering and put them in that same department under the leadership of Taylor Eschpeter, who was previously city engineer. He should be a known name to most of the players in town. So look forward to having wholesale the development officers and the engineering development sections in one department working much closer together. I'm really happy to see that change, and we'll see how it rolls out. I think it's going to bring a lot of efficiency to the development permitting process. Having all the staff dealing with the DPs under one direct report. Um, and and potentially there's other small changes coming in the organization that I don't think will really impact the construction or the design industry, so don't need to really talk about them too much. But maybe in closing, just once again, honestly and sincerely, thank Ken for his time and efforts that he's put together for the city and for our local industry. And yeah, don't expect. I mean, congratulations on your new position with the
Mhm.
province. I think some of the services we're hoping to get out of you, like you said, they'll take a little bit longer, and maybe we hand the torch off to somebody else for some other things as you go through your own changes. But sincere thanks. Really appreciate the way you've pitched in to help us come together as an industry and help educate the department and the industry together.
Yep. And thank you. And I hope to get up there uh, this summer and for a bad round of golf or something. So yeah, thanks again. And I'll keep in contact with the industry as we develop the building permit guide. I'm looking for some input on that side of the counter as well.
Yeah, so with that, it's a wrap. Thanks, guys. See if I can figure out how to stop recording.